Hi. So we'll talk a lot about Project Gemini. It's not very relevant to the customers or the users, but it may be for those who are interested in how we are testing Scylla. So let's get started. I'm Roy. I'm managing and testing Scylla for the last 3 years. And I'm usually the guy who delivers the bad news while we're trying to release Scylla. So what is Project Gemini? So Project Gemini is a testing tool that we designed to detect data integrity issues. Issues like data loss, data corruptions, very hard to detect, and we came up with that tool. We are using Gemini by applying random testing on a system under test and validating the results against a test Oracle system. I'll elaborate on that. It was started on 2017 by several guys in Scylla, and it was implemented with Go programming language. So the need. So the need came from the fact that we had some good tooling around testing availability, stress, load, performance, but we lack a good tool to detect data integrity issues. The tools that we were using were limited to certain types of schemas. They were fragile to schema changes and very hard to debug or to reproduce when such issues were suspected to happen. So we wanted a tool to detect those rare issues and be able to reproduce when such issue is detected. So how does it work? Every time we test, we have two systems. One is the system under test. Usually it's a full-blown cluster from several nodes, and the test oracle, which is, it can be a cluster or a single node, either Scylla or Cassandra. Sometimes we test ourselves and compare ourselves to Cassandra to make sure that everything is the same as Cassandra is. And how it works, so we have the data stream operations. First we generate a schema that will be used during the test. The schema is randomly created or can be supplied. We generate random SQL operations on both clusters at the same time. So both contains always the same data. And we query both clusters and compare each query results to make sure that they are the same. So as I said, the schema generation is random. We can repeat the same schema using a seed. We generate the random values for every column and every table according to the schema. We are running many threads in parallel, each responsible for a key range, so we will not have collisions between threads. And each thread generates either write operation or read operations. The write operations are somewhat simple. They are insert, update, or deletes, while the read operations, which are being used also to validate the data on both clusters, they are more complex. We are using all kinds or almost any possible query that is possible on Scylla. It can be a specific key. It can be range with limit, secondary indexes, materialized views, and things like that. So this is a command line example of how we run Gemini. There are several parameters, and there are even more parameters. Control when to stop, the duration, the SQL features that we want to test, with a basic, normal, advanced that use things like materialized views. We supply the test cluster and supply the Oracle cluster. So how we use it in the QA? We integrated the tool into our main repository, which called Scylla cluster test, or in short, we call it SCT. If you want to learn more about SCT or how we test Scylla, I had a session about it in Summit 2017. It has like 30 minutes about SCT and how we test it. So SCT is responsible for, in this case, it's responsible for deployment to clusters, both the system under test and the test oracle. It can be either the cloud or bare metal clusters. Deployment of the client that runs the Gemini tool. It triggers what we call Nemesis. Nemesis is a concept that we took from Chaos Monkey approach. It also, as part of my session that is in the link there. So the Nemesis, it can be either disruptive operations on the system under test, or administrative operations that are non-disruptive, usually like no tool commands, repair, refresh, things like that. During the entire test, SCT also searched for errors on the nodes, like core dumps, exceptions, anything that may be an issue. And finally, it analyzed the Gemini output and sending full report to the QA group. In case Gemini detects any difference between the system under test and the test oracle during the test, it stops the system, it stops the test and leave the system in a stage we can go and analyze what happened. Few samples of the test reports. Here is a test report that passed. We can see the details of the system under test, the version, the types that were used, and the test oracle that was compared to. And we can see the test results, how many write operations and read operations happened during the test. On the bottom of the report, we have also the list of the Nemesis that happened during the test. In this case, it was non-disruptive test with all these Nemesis running, and none of them has failed during the test. Another sample of failed test. Here we can see a report of a test that failed, and we can see that Gemini found a difference between the test oracle and the system under test. Then we are going and trying to analyze what happened, what is the difference, what are the rows that are missing, and we can also use our monitoring system that we added things in the QA. We added a way to annotate critical events during the test, and a way to correlate them to the Nemesis that we're running. So in this case, we saw that we had critical events during this Nemesis. We are going and checking what happened in this Nemesis, going to the logs, and it helps us to better analyze what happened during the tests, and then report the issues.